In this particular problem, we're asked about finding the slope or the derivative at a point, and the relation is written that we've got x's and y's all over the place. We're going to use implicit differentiation here. The derivative of that first term, won't it be a 6y y prime? The next term will be a negative 4x. The next term on the right side, the derivative of 6 will be 0, and then the derivative of that final term will kick the negative 2 out front. We'll take the first times the derivative of the second plus the second times the derivative of the first, which is 1, of course, and we've got it differentiated. Now, when we're asked about a point, we don't have to do get anything isolated. We can just put our 3 in for x and our 2 in for y. So if we put our 2 in, don't we get a 12y prime here? And if we put our 3 in for x, don't we get a minus 12? If we go ahead and put our 3 in for x, don't we get a 3y prime? And again, if we put a 2 in for our y, don't we have a plus 2 on the end? So now let's go ahead and take our 12y prime and realize that we've got a negative 6y prime on the right side. Bringing it over, that'll make 6 more y primes to the positive. Taking our 12 over to the right side, won't that be a 12? And don't we have a minus 4 over there when we distribute the negative 2 times the positive 2? So now we've got 18y primes equals an 8. And if we divide both sides by 18 and reduce our fraction, 2 goes into both, don't we have 4/9? And isn't our solution therefore B? On number 27. Number 27, we're given a function and we're told that g of x is the inverse of that function. Well, some people find this rather confusing. They know that if g of 2 is 1, then f of 1 must be 2. And if you put 1 in, you quickly find out that f of 1 is in fact 2. Some people never realize, though, that we have a relationship between the slopes. For instance, if we have a line whose equation is 3x plus 5, wouldn't the inverse be x equals 3y plus 5? And if we did some trading around with the x's and the y's, wouldn't we get that 3y equals x minus 5, or that y equals 1/3 x minus 5? So this is the inverse, right? And this is the original. Notice there's a relationship between the slopes. The slopes are always reciprocal. Not negative reciprocals, just reciprocals. And so for this particular problem, the derivative of the original function, wouldn't that be 3x squared plus 1? And if f of 1 is 2, there's an implication here that f of 1 is 2 because, f and g are inverses of each other. The slope at 1 would have to be simply 3 plus 1 or 4. And therefore, the inverse slope at 2 would have to be 1/4. And so the answer is B. That's kind of a hard problem, I think, to keep all that straight. Number 28 says we have a twice differentiable function, and this twice differentiable function, we're told that the first derivative is positive, so that means that it's increasing, and the second derivative is positive, so it must be concave up. And it says that at 4 and 5 we know some values. So like at 4 we know that we're at the position 12. and somewhere down the line at 5 we know that we're at 18. So if this is increasing, we know that at 6 it has to be greater than 18, and if it's concave up, this difference, between the first two at 4 and 5 was up 6, right? So this next increase must be greater than 6. So we have to be beyond 24. This has to be greater than 24 up here. And so none of these numbers will work, not even 24 itself. It must be 27. We must be up at 27 to get that thing that's increasing and concave up. This ends the section A, as it's called, the 28 multiple choice questions, no calculator. Now after a short break we go into section B, and in section B you can use the calculator. There's 17 more problems, and they start with number 76, and that's only because when you turn the answer page over it starts with number 76 at the top. It's a universal answer sheet. So for number 76 I've done a little work with the calculator and pasted it in already, but we're supposed to talk about acceleration at time 4. You're given the velocity function, and sometimes it's just quicker and easier to by hand make a calculation for what's the derivative of this velocity function. So a of t would equal, well, the derivative of 3 is 0, and then it would be 4.1, and the derivative of cosine is a negative sign, and it would be that 0.9t again, right? And then the times the derivative of 0.9t, which would be a 0.9. So the first thing I'm doing over here on the calculator, I'm finding the product of 4.1 times the 0.9, right? I'm taking those two and I'm bringing them together. So I'm saying a of t is equal to, well, I see this negative sign in front here too, right? This is a negative, not a subtraction. So it's going to be a negative 3.69 times the sine of the product of 0.9, the sine, excuse me, the sine of 0.9t. Well, if I'm going to put a 4 in, and that's what I'm going to do, if t is equal to 4, it seems to me that 0.9 times 4 is 3.6. So I went off to the calculator at this point and made that calculation, and that's how I come up with letter C. And finally, for this grouping, we're asked about finding the evaluation of an integral. This one's a little tricky in that, well, first of all, this the integral of this sum is equal to the sum of these two integrals, negative 3 to 3 of f of x plus negative 3 to 3 of 1. Excuse me for not writing my dx here, kind of a bad habit. So the integral of the sum is equal to the sum of the integrals. Well, maybe you were already thinking about these three regions A, B, and C that are all said to be 2. And we know from the properties of integrals that this area below the axis is going to be signed to negative, and this area above will be signed positive. So those two will net to 0, A and B, and all that will be left will be C between negative 3 and 3, and so this portion has to be a negative 2. Now to that you're going to add, and the integral of 1 is x, of course, and the upper and lower limits are 3 and negative 3 respectively. So we have a negative 2 plus, on the upper limit we have a 3, and then we have a minus 3, which will give us a 3 plus 3, or a 6, and a negative 2 plus 6 gives us 4. And so the answer here is C.